Good morning, class, and welcome to this lesson on Magnetism 14, generators and motors. Today, we will be able to describe how both motors and generators work. So we're just going to give a basic description of each one of those, because these two things, which are very important to how most things we use operate, it's all based on magnetism for the most part. So let's start off with generators. Start off with a generator. A generator, when broken down into its simplest terms, is simply a loop of wire, or a loop of a conductor in a magnetic field, being rotated. A generator is simply a loop of wire in a magnetic field being rotated. So, what's happening here is that down here, there's some force down here that's causing this thing to rotate. There is some force down here at the bottom causing this thing to rotate. So, because there is a force causing this to rotate, what's happening here is as this thing rotates around and around, the flux is changing. Which is inducing a current. So we have an induced current. This current travels to these wires, powering our devices. Okay? So basically, the basics of all this is very simple. Something has to rotate this wire mechanically. There has to be some sort of force, some sort of mechanical force to rotate this object. So what we do is we make mechanical energy. We take mechanical energy and we transform it into electrical energy. We take mechanical energy and we transform it into electrical energy. By us putting energy into this wire and rotating around and around, we will get electric energy in this circuit here due to this magnetic field existing. So, a generator works by converting mechanical energy into electrical energy. Someone or something has to cause this thing to rotate, which will then provide a current in this circuit. Something or someone has to cause this thing to rotate, which will provide a current in this circuit. Okay? And the sad part about it is, a good generator is about 40% efficient. It's about 40% efficient. And that's a good one. Meaning if I put in 1,000 joules into rotating this thing round and round, I'll get out about 400 joules in electrical energy. Okay? And as you notice here, one more thing, as a thing rotates round and round, every time it makes a rotation, the current is going to change. So every rotation, we have a changing current. Every rotation is a changing current. And this is where we get alternating current, AC power. Because this thing flipping round and round will cause the current to change due to Lenz's law. This is due to Lenz's law. Will cause the current to change direction. So the current is changing very, very quickly, many times a second, about 120 times a second, okay, or 60 hertz. So whenever you hear about power plants, these giant turbines that you see in this picture right here, very big. You can see the little guy right here in the corner. These turbines are huge. What are these turbines? These turbines are essentially giant coils of wire. These are giant coils of wire that are being rotated. And how they're being rotated is where we get the name for the power plant. We might have a hydroelectric. Where water flows downhill, pushing some sort of mechanism like a paddle. That is connected to a loop of wire, causing this loop of wire to rotate in a magnetic field. That's hydroelectric. Nuclear power. We are generating heat from nuclear reactions. That heat is heating something up. I believe it's just water, which makes it flow. That flow of water turns a turbine, which is just a loop of wire in a magnetic field. So we have nuclear power. We have geothermal power, which is the same thing. We heat up water, that water flows, causing these things to rotate. Coal. All these things, all these types of energies that we hear about, are just simply causing a turbine to rotate, causing a loop of wire to rotate in a big magnet. Okay, so that is a generator. Mechanical energy gets converted to electrical energy, and a motor is the complete opposite. A motor is attached to some sort of battery. Okay, it's attached to some sort of battery here. Okay, so we have a battery connected to this motor. The battery provides the current. So in a motor, we have electrical energy. Converted into mechanical energy. So it's just the complete opposite of what a generator does. So this would be a DC motor. A DC motor provides a current. This DC motor provides a current. This current has its own magnetic field. This current has its own magnetic field. And what happens is this magnetic field will oppose the magnetic field present, and so these two magnetic fields will oppose each other. So there'll be a force there. There'll be a force due to opposing. There will be a force due to opposing magnetic fields, just like if you bring two magnets together like this, north and north, they will repel each other. They will repel each other, and that'll cause us to rotate. This coil of wire is hooked up to some sort of shaft, some sort of something else, and this will cause something else to rotate, more than likely like a wheel. So we are taking electrical energy and we are converting it into mechanical energy due to opposing magnetic forces. So you can kind of see here how these two things are opposite. They're opposite in how they work, but they're almost the same. It's just this idea that all of our power really comes from this current, this idea of current. Where does that come from? This current comes from rotating coils of wire in a magnetic field. And this is why it's so important. So, just to recap: generator, mechanical energy converted into electrical energy, and a motor is electrical energy, a DC motor is electrical energy converted into mechanical energy.